We're going to take a look at Watershed Analysis. This is a command found under the Watershed pull-down, second from the top, Watershed Analysis, and you're asked going in to load your TIN or grid file for the site. This is the final design TIN that I'm loading. There are many applications of the command. One very useful application is drawing low points or sinks. To do this, we recommend that you put in a low rainfall amounts, so the very small localized sinks are found and the water doesn't quickly fill them and spill over to the next one. A higher rainfall will locate only your larger sink locations. Now with this rainfall set at 0.001, we can go straight to draw watersheds. Draw watersheds draws whatever is selected in the middle area. And I would also point out while it's working that prior to drawing your low points or sinks, if you hit symbol options, you can set the symbol that'll be used for any aspect of the drawing. In this case, for the sinks, we're going to use SPT5, and you can see that's the filled in solid circle. These are inserts, and these inserts can be used in the storm sewer command for locating your inlets at precise low points, which then lead to accurate calculation of the drainage into those inlets. Now, there are many other applications of this command. If you go to the Tools tab, there's runoff tracking. And in this command, you can click on any part of the site and watch the runoff path into the selected low points. So for example, if I click on lot 82 right here, the water finds its way into this low point to the left, and if I click on portions of 82, you start to see the break off from one watershed to another. And also in this command, you need to end the command at the command line, and then you return to the dock dialog. There actually is no command line per se in Watershed Analysis. You have no access to the pull-down menus. It kind of takes over the operation of the program, and the only way out is through the exit option. Now, if you grip on these runoff lines, you can see how they track to their respective low points. So I would point out that another way to find low points is actually to do runoff tracking, because runoff tracking will, in a sense, end at the low points and reveal where your watersheds break off, where one watershed ends and another begins. If you do enough of them, runoff tracking itself is a form of watershed perimeter location. However, if you go back into the command, Watershed Analysis, and we'll load the same TIN, you can turn off sinks and draw the filled, shaded watershed areas by the command draw watersheds. Again, it goes through the entire calculation of the site, finds all watersheds, and then delineates them with a solid fill. Now we'll exit the command, and you can see as you move your cursor into these distinct watersheds, they are highlighted. And note that they break off right at the center of the road, which is a sign of a high quality DTM. They're going right to that center line in all cases, both of the main road and the side road. Now we can hit, and we also notice that the runoff tracking lines are contained within their distinct watersheds. Now we're going to hit undo, which just removes what we did last, and just review up close the runoff tracking lines. You can highlight them and see them in some detail. Now the application of this command, of course, is to, within the sewer network program, to create your sewer structures by the option pick using the insertion snap at one of these low points, and then the watershed above is precisely calculated. Now, there's a few other commands within watershed analysis that we might point out. We'll go back in one more time. Let's say you were interested in just a very localized watershed. In other words, we know a very broad watershed feeds into the low point shown in the lower left of the screen. But what about if we want to do a watershed above the driveway in lot 81? So we can say, show me the watershed above a line. And here it is going through the calculation to put the watershed full analysis in memory. Now what we're going to do, if you follow the cursor here, is we're going to pick a line across this driveway in lot 81. This will produce not the entire watershed, but a more localized watershed. So we'll pick on one side of the so-called stream, and then on the other side of the so-called stream here, and then we get a localized watershed shown. Let's exit out and grip on it, and you can see that watershed would apply to, let's say, a on-grade inlet placed on the left side of the driveway there in lot 81. That would pick up the watershed shown and would be sized accordingly to be able to draw in that amount of water in whatever your defined rainfall event is. Okay, we'll go ahead and erase that perimeter there. That's another application of watershed analysis. Now let's load a different file, school project, and let's show the distinction of larger rainfall event and smaller rainfall event on the watershed drawing. So let's take the rainfall up to 5 inches and just fill the watershed areas. That's our selection, and then we'll draw the watershed. Again, it analyzes the entire site. What we have here is a school building, a play area in the back, driveways coming in, and a designed pond at the lower portion of the site. And you can see from the drawing that we get one big green watershed over the northern portion, and then a large brown watershed over on the eastern portion of the site. Now, if we take the rainfall down to 0.001 and draw the same watershed again, it goes through a fresh calculation given that the rainfall event has changed. And what you should see is more distinct watersheds, as smaller watersheds that have in a larger rain, a spillover effect begin to appear. So now this northern watershed area is broken out into 2 parts, and I believe there are other smaller distinct watersheds distinguished by this lower rainfall amount. Another thing you can do is draw pond areas. So if we turn off draw the fill areas and instead draw pond areas, this will focus in on the ponds. And we'll draw the watershed first at a 5-inch rainfall. This does a fresh redrafting of the graphics after a full analysis. I've changed my rainfall event. We've designed on purpose a pond in the lower right of the site, and notice though that it's actually found a low area at other locations. Let's hit exit and study this. we have our deliberate pond area found, but there's a localized pond area just to the west of it, and there's a general low area around the school building, and that's true. We're feeding into a starter inlet at M1 on a storm sewer system, and so at the corner of the building there is a low point that's drawing the water from the downspouts and from the play area in that zone. Now, one thing you can do is, if you have a low area found, you can use a command in the hydrology module called stage storage, calculate stage storage. So we can find out the amount of water by calling up our tin in this particular perimeter. And we'll do the automatic option. Top of dam is 675. It's looks like it's 8 or 7 feet deep, and it has nearly an acre foot, 0.87 acre feet, and that's calculated directly from the DTM. And you can even write a stage storage curve, which is useful for pond and spillway design. And we'll put together a capacity file called detention pond. This is a file that can actually be drafted, which we'll show next. You can go to draw the stage storage curve, and we'll select the file, and we have the top of structure correct, emergency spillway, principal spillway, and clean out level. And we will go ahead and hit OK and plot the stage storage curve. You can see it has a gradual arc of a typical pond stage storage curve, and it's every aspect of this is controlled by you, the user, and your business address can go here. So a lot of automation from this process, but we could also draw a perimeter around this other area and just get a sense of its stage storage. Does it have anywhere close to 0.866 acre feet? We'll find out. We'll draw a quick perimeter, C to close, and take a look at its stage storage. Read the applicable tin, click on it, and we'll do interval method, a different method this time. The top of the structure is 678.31, but it's only 3 feet deep. It's a very localized low area, and we'll do a 0.5 stage, and it has nearly the same amount of water, 0.8 acre feet, and that's revealed. We won't bother saving its stage storage file, capacity file, but these are all revealed by the pond feature within Watershed Analysis. Now, the applications of Watershed Analysis are for detention pond sizing and determining drainage areas, storm sewer design for determining low points and the associated drainage areas to them. But we would point out that where you have a file that involves a site where you want to get drainage into low points, but your DTM maybe is not accurate enough to reveal the precision you're looking for. In this case, we highly recommend that you literally draw the perimeters feeding into your inlets for storm sewer design. So here we've drawn a perimeter that uses some human judgment, where this building, the front of it would drain to the street, the back of it would drain out in the westward direction and feed into this inlet. Similarly, this next drainage area shown here would feed the next inlet, M2, and again, it would capture all the water from the edge of the road flowing downhill in the northwest direction to M2. So it's important here to realize that for storm sewer design, coming directly off the DTM may not be practical. You do in some cases need to draw these perimeters yourself. However, the runoff tracking command, both found within Watershed Analysis and found distinctly in the pull-down menu, can be useful for tracking where the water flows and guiding the process of hand drawing the perimeters. So that's a little tour of Watershed Analysis and some of its uses.